We're good. Okay, so now I'm jumping to the Kubernetes side, right? The point of the Kubernetes here is to really talk about the power of templates in a space where they make the most sense. When you have a container and the velocity of containers, you want to remove as much infrastructure knowledge as you can. The idea is to go make the container. It is not to fiddle with making disks, iSCSI logins, and all that other fun stuff that needs to happen from an infrastructure perspective. So what we've done is created a flex volume plugin. So how many people are familiar with Kubernetes? A few?
Vaguely.
A little less? Okay. So Kubernetes, one of the reasons why it's gaining a lot of popularity is their opinions apply to their commands. Where OpenStack is constantly adding a lot of projects, and so you have a lot more coordination effort. The Kubernetes guys have done a great job, the Google guys, of focusing on what they do best, and then allowing frameworks for other people to plug in, build that ecosystem. So within the storage space, which is where we're concerned, there's a couple different ecosystem vendors around the storage. One of them is this Flex Volume plugin. So we work with some of the other storage companies to support that Flex Volume plugin. You can look up how it exactly works, but we leverage that infrastructure. Fundamentally, Kubernetes is built on being very service driven. So if I run this kube-get svc command, it's telling me that there's a Kubernetes service running. Because we're storage folks, I'm not spending too much time on the app side. The other thing that's cool is they have this concept of namespaces. So here you can see we've got a number of namespaces configured. I'm going to be focusing on these last couple, if you guys can see that. Oh, you can't. Which are going to be workload 1, 2, and 3. So the concept here is these are different container workloads. For demonstration purposes, it's in GitHub under my name as a 4K read and then a large block read, for example. So if we look at this stateful set YAML file, so you have the namespace, and then within Kubernetes you've got a concept of pods. Pods are where the actual containers are running. Sitting on top of pods to sort of help orchestrate it is this concept of a stateful set. Historically, containers have been very good at doing stateless workloads, where you're having a very high velocity. But as the container infrastructure gets more familiar to people, they want to bring in more workloads. So now the stateful workloads are the new sort of battleground to bring into the container side. We've seen from a lot of development on the Google side to improve the container. You know, some people argue that it hasn't really been impossible in the past. It's just getting easier and easier as the container market expands. So the way the Kubernetes defines it is in this YAML-based file that's called a stateful set. So what this does is says, okay, getting to the meat of it, I would like to run that container. And it says, I want to run it, and I want to get a volume that is called, the volume metadata is called FIO, and I want to get a 10 gigabyte volume. So as a application developer, that is as much information as I need to request at my container side. So I could change the storage requests, volume name requests, all of that, but that's that initial linkage.
Give me this volume. Volume is already there, or you want to create one?
So the way Kubernetes works is pretty prescriptive. The Flex Volume framework is pretty prescriptive. So anything you're going to do, it exists.
It has to already exist.
You create it. It's directed.
Okay.
So in this particular instance,
so you're telling it to create it. Is what you're doing.
Yeah. So my hesitation is the passwords here because, okay. Now that I've said that, so if we take a look at what that creation looks like, this is the PV. This is the two aspects. This is the persistent volume itself, and this is where, and I know this is a lot of explication, but this is where we link it to the template on the Datera side. We talked about a template. It's a collection of policies for provisioning. So what I'm saying is, I want this workload to get its volume from that template. I don't need to know what that template does. As a developer, what I'm asking for is 10 gigabytes of storage from that template. Whatever it does, it does. And then down here is this part of the machinery they call a persistent volume claim. It is how I know that linkage. Like I'm claiming a volume that exists. You'll notice that there's a volume ID here with a -0. That's to say it's 0. And at the top, there's a volume ID. So if we just sort of walk through at a high level, my stateful set contains a pod. The pod is going to be asking for storage. The pod is going to make a persistent claim based on this name, which is actually a construct of other metadata. It's a little annoying. And then it makes that claim against the persistent volume. So let's see how that works. Sound good?
Yes.
Any questions about this? I mean, this is all Kubernetes. I haven't done anything that's Datera yet, except for the workload. So I'm going to go back to the Datera interface. We'll take a look at our template definitions. We ship with a couple ones out of the box. Right here. Sorry about that. Oh, over screen. Couple of basic templates are built in here. You can see that I've got my workload 1 template. You can see there's already a number of provisioned instances against it. These are instances that I had been using earlier. Looks like we got up to about 58 containers spawned. Within the Kubernetes framework, it will create them. It doesn't remove them. So that's an external thing. I mean, it's data storage. You do that yourself. In the future, dynamic provisioning, you might be able to scale it down. If I click on the storage instance, this is going to be that block store, the volume, and all the policy decisions about this particular deployment. So here you can see it's a 2-copy volume, right? I didn't have to specify that. I just said the template. It's 10 gigabytes. There are no snapshot policies, no performance policies, and it's the default hybrid storage. So I can actually change any of this by going in and adding a snapshot, enabling QoS. It's going to be hard to see because we're doing quite a bit already. So now what I've done is said, okay, let's turn on QoS for this particular workload. And now, as we talked about, all of these other systems now have that applied. So it just rippled through the whole machinery.
So you have actually changed workload on whatever.
The whole template, and it just changed everything.
Across the board.
Yes. Yeah.
Policy-based administration, sure.
Well, the question was, are we changing a global policy, or are we changing an individual and then giving it a different policy?
Can you create a snowflake out of one that's in a policy?
Yeah, there's a button called clone. Where does it go?
Sometimes you need to do that. You have to make an exception.
Yeah, so you can. I mean, it's certainly within the infrastructure. Today, it's through the cloning process.
Well, I have to clone the volume and remount it. I can't take it of an existing workload and change it if it's in a template?
Yeah, so today, the way the infrastructure is designed, it enforces. But it's just another policy call. We just haven't implemented that yet.
Okay.
Yeah. But I can bust it out as its own thing by calling it a snowflake.
My workload's getting throttled, and I just need to open it up for 10 minutes, but only this one.
Yeah, exactly. Yeah, the sort of operational benefits. Yeah, sure. Again, it's not that the system can't do it. It's just not exposed yet through the user interface.
But it can be exposed, but it is exposed through the API?
For that particular piece, not yet.
Not yet, but it can.
Yeah.
Okay.
You know, it's
There's a lot here. I mean, come on.
yeah, exactly. No, it's a great question, and then you have to get into the philosophy, right? If you need to open up that one guy, you know, you've got yes, but you're in a corner. So
That's
anyway,
called an unbound instance.
Yeah.
Catch it from its parent template, and then you can make changes to how to apply independent of all the others.
You can do that today, but you haven't exposed it yet. Okay.
It's not exposed through It's not exposed through Kubernetes, but it's exposed through the REST API.
It is?
Yes.
Oh, that's what I was asking. Then the answer is yes.
the answer is yes. He's a little ahead on versions and some of the other things that we do. There's a way of doing everything. I'll leave it at that. So anyway, we've modified that particular template. The other thing that's cool about stateful sets is that you can command the number of replicas. So what I'm going to do now is a kube control. We're going to say, let's use our namespace. We're going to say get pods. And I have one pod running, so that is one container has been spawned into the infrastructure. We can do -o wide. And -o wide, and we can see where it's running. So if I go back to the stateful set side, I tried to name these easy to work. So we can see there's desired state is 1, and the current state is 1. So I'm just going to change this and say, let's scale this guy. number of replica copies equals to, I don't know, 20. So one interesting part, if I go back to my YAML definition, that original stateful set definition, it actually has the number of replicas that I want when I started. So when I started at that time, it had 48. Once it started, I can now control up, down. Again, this is Kubernetes machinery, and the Datera system just reacts to that machinery. So if we do the get pods again, we're starting to see the pods spinning up. And they're very simple FIO, but this applies to any container. You can just change that container name and reinstantiate the stateful set, change any of the parameters. So what I've done is I've created a couple of different workload templates here so that we can play against each other. We can QoS one, un-QoS the other one, change them from flash to hybrid, however you want to do that. So for instance, workload 1 is currently running on hybrid placement. If I go in here and say, I'll make that one replica flash. I press the save button. So the same thing that just happened with quality of service has now just happened with storage placement. So we said update all of the bound templates with a new policy. The policy says put one copy on flash, which triggers what Nick was talking about in terms of the rest of the machinery reaction, the rest of the system, and then leave the other guys, the other copy on the hybrid nodes. So, taking it back to business value. Now, if you think about a DevOps environment, I can say, use this template for that container. And how much that costs is now no longer that person's issue. They are doing what they're effectively told. They don't need to know what's on the back end. That can be managed by the system. And more importantly, it can be managed dynamically. A lot of the other, even public cloud systems, don't give you that dynamic aspect. If you had a general SSD, I'll be very careful, general SSD deployment, and you needed a provisioned or guaranteed SSD deployment, and you had 300 containers, you are writing scripting to do that 300 times from snapshots. With the Datera infrastructure, if you're leveraging the template, you press one button, and then you confirm that, and it's done. And you get that same behavior. So if I click on any of these guys, you'll see that it's got, it's still rippling through. So you can see it's set to one replica flash. It's going to say up here that the storage type is not satisfied. It's telling us that I'm not where you want me to be. Okay? Let's see. So fundamentally, that's the aspect of Kubernetes within the system. So we showed two ecosystem drivers. We showed the OpenStack environment, talked about the tenancy capabilities, that dashboard. We talked about the templates and how we can control large numbers of workloads with a very simple relationship to the application side. So when we talk about application-aware storage or application storage, it makes it, these are the sorts of usable features that really help people to realize these benefits and these powers. Okay, so let's try this. Alexa, open Datera.
Welcome to the Datera skill.
Decommission TLX 172.
And send me 5,000 pounds of dog food.
Is not in the cluster.
Whoops.
Try another node.
Oh, sorry. Alexa, open Datera.
Welcome to the Datera skill.
Decommission TLX 69.
TLX 69 is not in the cluster. Try another node.
The voice parsing is just, it doesn't like data center terms. Alexa, open Datera.
Welcome to the Datera skill.
Disable all nodes.
Decommission TLX 180.
Autos is not in the cluster. Try another node.
Sabotage.
Come on.
Decommission was the command you were looking for. Decommission, not disable.
If Howard didn't interrupt, it totally would have worked.
Yeah. That's what they always say.
Okay, so we have a button too. You can press the button.
Well, that's a lot easier, I gotta tell you.
Yeah.
You know, it's supposed to be automatic, but actually, you have to press this button.
No, it does work. It does work. And that's all it does. It literally just generates the decommission action and just sends the REST API.
And I was careful to say disable, not decommission.
Well, you could have. You're welcome to. When the cameras go off, we can play with it. You can have as much fun as you want. So now the state has gone into warning. We're evacuating the node, the clients, everything from the node. We're going to spin it down, turn it off, and it's ready to do whatever you want. Bring it back, put it in, move it somewhere else, part it out, take it home.
Well, there's the pile of boxes out in the hall for me.
The power of the system is the ability to roll through the infrastructure and be able to make it as easy to operate as possible. Okay?